So in our next video, we're going to find all of the points a specific distance away from a given point that lie on a given line. So exercise 4 says find both points that lie on the line y equals 3 that are 10 units away from the given point 2, -3. Before we begin, I just want to imagine what this is looking like, so I will draw you a picture. In my coordinate plane, I am imagining the point 2, -3, and a line y equals 3, and this line extends horizontally left and right forever. Now, the shortest distance from this point to this line would be a perpendicular line from this point that is perpendicular to the horizontal line, so that vertical line. Now that distance, because it's a vertical distance, I know how to find that. That's 6 units away. That's the shortest a distance is from a point on this line to this point is 6 units. Now, if I go to the right and continue to go to the right on this horizontal line, my distance gets farther and farther away. And I'm imagining that eventually will extend from 6 units all the way up to a length of 10. But when it says both points, that implies that there's more than one. What if I have gone to the left? I imagine there'll be a point that is also 10 units away from the point that lies on this line. The last clue happens to deal with the equation of this line is y equals 3. Since it's y equals, every point that's on this horizontal line, we automatically know its y-coordinate. Its y-coordinate has to be 3. So what I'm looking for is I'm looking for two x-coordinates, like x sub 1 and x sub 2. Two x-coordinates that have a y-coordinate of 3 that's actually 10 units away from the given point. Okay, so let's begin. I left the distance formula at the top here. What I'm going to do is try to fill out this distance formula as best as I can using all of the information we were given and all the information we figured out. The first thing I notice is we are given a distance of 10, so I can plug 10 in for D. I do know the y-coordinate of the points that are indicated are 3's, but I don't know the x-coordinates. So what we do have is we have a first point. I'm going to use the given point as our first point, and then we're going to use these 2 points that I drew. We're going to call these our second points. So I'm going to write x minus, and I'm going to take the x-coordinate from the given point, and then the y-coordinate of the point we are looking for minus the y-coordinate of our given point. So I filled out this formula as best as I can, and I only have one variable that I'm pointing to. What I can do is I can simplify this expression and solve for x. First thing I'll do is I'll simplify this expression. 3 minus a -3 is 6. And 6 squared is 36. Next, what I want to do is to solve for this x, I'm going to get rid of this radical. So I'm going to square both sides. 100 equals the quantity x minus 2 squared plus 36. Next, because there's addition, I want to move that to the other side because I always reversed the order of operations. So I started with parentheses when I was evaluating, but parentheses is the last thing I undo when I solve. Let's subtract 36. And let's square root both sides. I can't subtract the 2 unless I get rid of the squared first. What you might notice now that you may have wondered about previous to this was in my warm-up I didn't use plus or minus when I square rooted for c squared. In the warm-up in the beginning of the last video. That's because distances are never negative. Because I'm looking for coordinates, it's possible to have a positive 8 and a negative 8 when I square root both sides. So I do want to square root both sides, put a plus and a minus here. This gives me 2 x coordinates. What are they? Using the plus, 2 plus 8 makes 10. One of the points is the point 10, 3. Using the minus, what's 2 take away 8 would be -6. The second point we were looking for is the point -6, 3. We've identified 2 points on the line that are 10 units away from our given point, and these are their coordinates. We're going to try that again one more time down below. First, I'm going to write my distance formula. So it's the change in x squared plus the change in y squared underneath the square root. That tells me the distance. Find both points on the y-axis, okay, that's code for something, that are 6 units away from the point 4, 3. This is my given point. I'm going to assign that x1, y1. We know they are 6 units away. I'll plug the 6 into my formula. Now, what is this the code for, the y-axis? Every point on my y-axis has the same x-coordinate of 0. So I know the x-coordinate of the points I'm looking for. I'm missing the y-coordinates. What we need to do is find the second y-coordinate. So this is what's missing. We can fill in the x-coordinate because we know if there's a point on the y-axis, its x-coordinate is 0. So I'm going to put 0 minus 4 squared plus, now I don't know the y-coordinate, minus -3 squared. I can simplify this expression. -4 squared is 16. I could simplify this a little bit by changing their signs. Minusing a negative is adding a positive. Next, let's square both sides. So 36 equals, excuse me, if I square both sides, I shouldn't have a radical anymore. 36 equals 16 plus the quantity y plus 3 squared. Subtracting 16 on both sides. Now we're going to square root. Plus minus square root of 20 equals y plus 3. Subtract 3 from both sides. And then here we have a little bit of a problem here. The square root of 20 is an exact value, but it's not simplified. The largest perfect square that goes into 20 is 4. The square root of 4 is 2. And the square root of 5 is what's left. So the two y-coordinates of the points would be -3 plus 2 root 5 and the other y-coordinate would be -3 minus 2 root 5. These are the 2 points that are 6 units away from our given point that lie on the x-axis. And that's how we do this section.